course we're ready. We're ready to add and subtract fractions because it's not just you. We're in this together. We have two strategies for adding and subtracting fractions. Now remember, with adding and subtracting fractions, you use the exact same steps, but in the end, you're either going to combine your numerators by adding or combine them by subtracting. So let's look at two strategies for our first, two ways to solve our first, which is common denominator. We have two ways. Our first way is by creating a picture or a graph. So we're going to create a picture by creating two boxes. We have a denominator of 4 and we have a denominator of 3. So I'm going to try to figure out a common denominator by drawing a picture. So for my denominator of 3, I'm going to split my table this way. And for my denominator of 4, I'm going to split my table this way. And this is what it looks like. So I need 4 columns. I have 2 fractions, so I'm going to make 2 tables or 2 pictures. My second fraction is thirds, and I'm going to try my best to make my boxes identical in size. It's human error. It's not going to be perfect, but we're going to pretend like they're identical in size. Because with fractions, we're dealing with identical pieces. All right, so here I have my boxes. And for my first fraction, my 3/4, that's going to go in this box, this picture. My 2/3 I'm going to do in this box. So my 3/4, I'm going to color 3 out of 4 of my columns. I have 3 columns colored in, and that leaves me with 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 10, 11, 12 total boxes. For my 2/3 fraction, I'm going to color rows because my thirds are going left and right. So 1, 2 out of the 3 rows because my numerator says 2. And that leaves me with a total of 1, 2, 3, 4, 5, 6, 7, 8 boxes out of 9, 10, 11, 12. Notice, by drawing a picture with the dimensions of our denominators, we wind up with common denominators. So with this, I'm now, because it's an addition problem, I'm now going to add, and I wind up with 17 over 12. 9 plus 8 is 17, and I can verify this because I have 3, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17 boxes colored in. Hence my numerator of 17. But I can't leave my answer in an improper fraction. So I need to figure out how many whole groups did this make. So I'm going to use division, and I'm going to say how many times does 12 divide into 17? It divides 1 whole time, so this is going to equal 1 whole number. 1 times 12 is 12. Subtract, I get 5. 5 is now my numerator. That's how many pieces are in an unfull box, a box with space. And my denominator doesn't change. So my answer is 1 and 5/12. So when I add 3/4 plus 2/3, I get 1 and 5/12. Okay, let's do this in one other way, and you can choose the strategy you like best. My other strategy is to find the common denominator through listing out multiples. Now we've done this before. I'm going to start with my 4 and my 3. I'm going to list out multiples of 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. Now I'm going to stop there because my second number is 3. So if nothing else, I can multiply 4 times 3 or 3 times 4. All right, 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. So in this case, I could have just multiplied the denominators to each other. That's my least common multiple, the smallest number that 4 and 3 have in common when multiplying. All right, so my new denominators, as we saw above, are going to be 12. Now, how do I figure out my new numerators? How do I make the numerator size the same sized piece as my denominator? Well, I start by asking myself, what did I multiply 4 times to get 12? I did 4 times 1, 2, 3. So I need to do 4 times 3. That equals 12. Remember, what I do to the bottom, I have to do to the top. So times 3, and I get 9/12. Similarly for 3, I multiplied 1, 2, 3, 4 times. So I need to multiply times 4. What I do to the bottom, I have to do to the top, and I get 8/12. Now my problem was to add these, so I still want to add them. I have 9 plus 8 is 17 over 12, but I don't want to leave it that way. So 12 goes into 17 one whole time. 17 minus 12 leaves me with 5 left over, and my denominator doesn't change. Same answer, 2 different strategies. Okay, what if you don't necessarily want to use the common denominator strategy? I have for you what I like to call the butterfly strategy. I know. Let's fly away. All right, the butterfly strategy, let's do in pink because it's beautiful, like butterflies. Let's choose the same numbers, just for the sake of choosing the same numbers to show you that it works. So I have 3/4, and I'm adding 2/3. Now with the butterfly strategy, I need to make my butterfly. So I'm going to start by drawing the wings. And of course we need the antennas. Oh my gosh, look at our beautiful butterfly. Just like comparing fractions where we cross multiplied, in this case with the butterfly strategy, we can also cross multiply. So I get 4 times 2 is 8, and 3 times 3 is 9. I add those together, and I get 17. And lastly, I need to multiply my denominators straight across, which is 12. So I have 17 over 12. Hey, wait. It got me the same thing. 17 over 12, 17 over 12. So if I convert this into a mixed number, I should get 1 5/12. Let's look at it again, but with subtraction. Let's do 3/4 minus 2/5. Again, I need to create my wings. So 4 times 2 is 8. 3 times 5 is 15, but only this time instead of adding, I'm going to subtract. So 15 minus 8 is 7. And to find my denominator, I need to multiply straight across. 4 times 5 is 20. So I get 7 over 20. Now I have to ask myself, can I reduce this number? 7 is a prime number. It can only be divided by 7 and 1. So therefore, this is my answer. I could also check whether or not I can reduce this fraction by saying 20 is divisible by 2 because it ends in 0, but 7 is not. 20 is divisible by 4, but 7 is not. 20 is divisible by 5, but 7 is not. 20 is divisible by 10, but 7 is not. So therefore, that's my answer. All right, there are your strategies. You have 2 ways to find common denominators to solve, or you have the butterfly strategy. So go ahead and play, pause, and repeat as you need to practice.